Hello, today I am demonstrating how to use Xilinx software. So just trying to open. So let's start with a simple procedure. Go to File, New Project. So here I would like to save it in a different directory. You choose your directory. Normally I told that you create your own folder with your name. And this is the directory I just wanted to create, and this is one time procedure. After that you just have to locate this directory and just give the project name. So I am trying to do half adder first, so just I gave name HA, or you can give half adder as it is. Say next. So just keep this as default. If you wish, you can write a description of the project here. Okay, keep it as it is, and here you select. By default these things will not be there. If it is there, it is good. Make sure that you are going to select Spartan 3 XE3S400 PQ208. This is one of the kit that we have in our lab. If it is not there, you just have to select it from the drop down menu. Spartan 3 XE3S400 PQ208. So speed grade 4. And in the software selection, you just select XST by Xilinx, and iSim, which is a simulator. Again, it is from Xilinx. Preferred language, initially we are writing a program in VHDL. Later we can shift to Verilog, and keep the remaining things as it is. So this summary will come. This is about the project, where we have saved the project, what is the name of the project, what is the top level source type. This is all about the device, what we have selected. These are all about softwares and languages. So just say finish, and now we would like to write a program. Go to project, new source, or there is a shortcut here, new source. Just select VHDL module, give a name for VHDL module. So one click on this, give a name here. That's it. Make sure that it is selected. This add to project, by default it is there. You keep it as it is. Here I would like to give name for the entity. So just I am trying to give input and output. Sum and cout. Make sure that these are output. These are single bits, so I am not selecting bus here. If you are trying to select a bus, you just have to make them enabled and give MS VLSI. So just finish, and the template with the entity filled by the information what we have given, A, B, sum, cout. Blue color one, or as I already told, these are keywords. Pink color related to the library items and data type. Anything comes in black will be user defined. Okay, and there is something called library instance, like and 2, which will come in red. So those things must not be there. As soon as you write, all the identifiers, variables, signals, the names of the signals must come in black. Just ensure that. Okay. So VHDL is case insensitive. You can just make use of uppercase, smaller case, or mix of upper and smaller case. So this is about the program. Just I saved. I just hit Ctrl S, so you did not observe that. This is the 2-line program, and we would like to simulate it first. Then to simulate first, you just have to check whether the code is correct or not, either by simply double clicking on synthesis XST, or you can do check syntax first and then do synthesis. Okay, there are no errors. If you wish, you can continue to synthesis XST. So this is source window, this is project window, and this one is where you could able to see your code. This is the bottom window, which is horizontal, where you can see console, what is going on in the software, errors and warnings, if any. All those things can be observed here. Next thing, we would like to simulate. This is the first part that you have created the project. Second thing, now we would like to simulate it. So here in the source window, from the implementation you come to simulation. So these things you keep it as it is, behavioral simulation and all. And one click on, earlier this was selected, so one click on, for each selection you have different option in the process window. So if you select this, you don't get the simulation option. So one click on the code, VHDL code that you would like to simulate, expand ISIM, then simulate behavioral model, double click. So double click on simulate behavioral model. So a separate window opened. So we were here. So it is just opened some software called as ISIM, and we would like to give inputs and outputs here. There are two ways, again I already told. So one is force constant, another one is force clock. In this tutorial we are not writing test bench code. So if you we have a shortcut here. Without writing test bench we can able to simulate because it is a simple code. Let's do force constant, say 1, 0. So we have two inputs A and B, and we gave 1 and 0. Once you run, those values will appear here. According to that, outputs will change. So you force constant or force clock only to inputs. Can you see I and I here? So you should not force for output. That's a common mistake. So let me run it. So always do this, run for specified time. We have already, by default it is specified as 1 microsecond. So it will run for 1 microsecond and it will stop after that. So don't hit this, hit run for specified time. So I gave 1 and 0, it is appeared now. Someone carries 0, so it is working fine. Suppose if you have two inputs, we need to give all 4 combinations 0 0 0 1 1 0 1 1. If we have 3 inputs, we need to force and run 8 times. If we have 4 inputs, we need to force and run 16 times. This is going to be tedious task. So we have other options. If you have a single bit, it works only for which is not a vector, which is a scalar port. That means only one port, 1 bit port. So in that case we have force clock. And if you have a clock, like you are trying to write a code for counter, flip-flops, for clock you force clock, okay. So I am trying to do a simple one, so 100 nanosecond. For the other one, you give period as half of the previous or double the previous one. So previously we are given 100 nanosecond. Now we are trying to give 200 nanosecond. If you can also give 50 nanoseconds, which will give all combinations. Okay, just by one run. Let me show you what exactly happened. So this is the initial, afterwards we forced 1 and 0, it is here only. Then we forced a clock 100 nanosecond and 200 nanosecond. This is a zoom option. You can hit control and you can press control and use your mouse cursor to zoom in, zoom out. This is a simple cursor. Wherever this cursor is there, those values are visible here. So now 0 0. Can you see? 0 0 0 1 1 0 1 1. So 0 0 0 1 1 0 1 1. So all combinations are covered. According to that, output also changed. 0 0 0 1 1 0 1 1. So in this you just created all the combinations and you got the output accordingly. So what you can do, you can take a print screen of this, and let me take a print screen and go to paint. So we are in paint, paste it here, right click, invert color, select option, select a combination that you would like to observe. So make sure that you have all combinations here, copy, go to your directory. So this is the directory that I have. I think let me see where I have created EMPM. So in your directory, one time you just create one Word file, give name simulation, followed by your name is also a good habit, and say I am trying to save a half adder simulation here. So make sure that you just paste here. So next time you do full adder or something. Okay, you paste full adder, you paste decoder. Make sure that you just paste everything in one Word file. At the end of the semester, you can able to take a printout and also you can able to submit it along with the journal. Okay, this is what simulation is all about. So let me close the simulation. Now we would like to implement it. The third part is implementation. So come back, simulation is over, I just closed iSim. This also I don't want anymore. Okay, so we came back to ISE. Now we are in simulation, you come back to implementation. Here in the top left corner, in the source window, you just click implementation, and the options in the process window got just changed. Earlier these options were not there. Now as soon as you click these things, options are completely different. If you wish, you can go on again and do the synthesis. If you are not done, if you just did check syntax, you do synthesis. If you wish, you can also make observations here. You can check RTL schematic. What is the hardware implemented for this, you can able to check. You can also check many other things are there, technology schematic as well. So what exactly this value, I think I have explained the value, how these things will be stored and all, how your logic is converted into, how your code is converted into logic. This I have explained in the class. So the first thing is check synthesis XST, and now we would like to assign pins. Just above synthesis XST, there is something called user constraint. Open it, click any of these three. I prefer you to click the last one. So this is floor plan area IO. So where you are trying to assign pins. So pin numbers are given here, or you can just see the board, and we need to give inputs for Dip switches are push buttons if there are any. Outputs, you must be connected to LEDs, okay, or even many other things are there, output devices like 7 segment and LCDs. So at this point initially we are trying to use LEDs. If LED is on, logic 1, LED is off, logic 0. Let's look into the software, what exactly it is happening. This is plan ahead software. You just have to look into plan ahead means you are trying to assign the pins in this software. We were here, you just double clicked on this. We after 5-10 seconds this software opened up. This is called as plan ahead. So don't do anything here, there are many options are there. So just this is the device that we are using. If you wish you can zoom it and see. I wish I am just zooming it. So I told you to do these things in the class. So this is one slice. Together these 4 slices makes one CLB. So let's assign pin in the IO ports in front of site. Say for EA I would like to give P34. Either you can type it or you can simply get it from the drop down menu. So I am scrolling and getting it from the drop down menu. Switches are connected to 34, 35, 36. If you wish I can show you where switches are connected. You can see these are the switches that are connected, okay, and LEDs are connected from say 58, or if you would like to count it from the top, 68 to 71 top row, 58 to 71 bottom row. Total 16 LEDs are there. So you can able to see these numbers on the kit. So I am not focusing on those things. So let's now I am trying to assign P61 to carry and P58 to sum. Okay, for sum first, carry next. So make sure that this cursor is not blinking. Either you click here or one click on all ports. Okay, it is simple. So don't make sure that there is no cursor blinking in these site locations. Just simply click fixed or one click on all ports and save. Go to file, save, or there is a shortcut here, save, or Control S and close this. There is nothing to do further. Now you can able to see that whatever we just assigned, those things came in the form of UCF file, user constraint file. If you wish you can still change any of the locations here, or if you missed anything you can write it manually. So that must come and attach to your main top module. This is called as top module. This 3 dots. Next thing, double click on implementation, double click on generate programming file, double click on configure target devices. So I am clicking one by one, double click on one by one. So there is a JTAG cable that you need to connect. Meanwhile it is generating a bit file. So make sure that you have turned on the power supply, and a JTAG cable along with the small FRC cable is connected to the trainer kit, that is Spartan 3 kit. So double click on generate programming file. So just now we have created bit file, and once it is done you double click on configure target device, say OK. So here I do not have, at this point I do not have a hardware. So if nothing is coming here, you just go and click new or a new project, or if it is already coming with a new project, you double click on boundary scan and initialize chain. Okay, this must be done. So or directly you can take device, but initialize chain is a good option. Go to file, initialize chain. Once you I have not connected hardware, so I am not going to do it. Once initialize chain is done, your device should appear in this window. Okay, in this window your device will appear here, and it is giving TDO and TDI, making a complete connection. And then it may ask you to assign a new configuration file. So if it is asking for new configuration file, say yes. So our device is XC3S400, must come here. Here it must come. And if it is asking for assigning a new configuration file, say yes, and locate your bit file. Where to locate the bit file? Here. So you have to go to the directory where you just saved the project. And open that, locate your bit file. So as soon as you locate the bit file, so as soon as you initialize the chain, this must come automatically. This must come. This device must come, and this may not come. The HA.bit may not come. What you do, you right click on that, assign new configuration file, and locate your bit file. So it is by default going to the previous project. So make sure that you are downloading your own bit file. So say open and right click program. So this is the last option. Again, I am not doing it because I have not connected any of the hardware. So it is giving it is failed and all. You may get program failed if the cable is not connected properly. Make sure that the cable is straight, and then it must come in blue color as program succeeded. As soon as it gives program succeeded, you just look into the hardware kit for outputs. Okay, so I think this is sufficient.